This question is asking us to determine the limit as x approaches 2 from the right. So notice we've got that little plus sign in the exponent there of 1 over x minus 2. So what we're looking at right now is a right-hand limit. The limit as x approaches 2 from the right. I always tell people try option 1. You never know when option 1 is going to work and save you a lot of extra headache. Option 1 for me is always just plug this thing in. So you're going to take whatever x value you get and plug it in for x in the equation. So once we plug things in, we can drop our limit. We end up getting 1 over 2 minus 2, which is going to get us 1 over 0, which tells us option 1 failed. It failed because we get division by 0. That is bad, and so we can't use option 1. If you start going through the other limit options that we've talked about in the past, you're just going to kind of notice none of them are really going to work either. Option 2, factor and cancel, not going to happen here. So you're kind of stuck. And when you're stuck and you've tried all your other options, really the only game in town is kind of telling you that this is probably going to be a vertical asymptote. And so what you're going to do here is we're going to play what I would just call the big small game. Finding vertical asymptotes is a very conceptual process. You can't just do some algebra like you do with a lot of these other limit problems and arrive at that conclusion, because infinity itself, right, is very conceptual. And so what we essentially do is we're going to play the option 1 game. We're going to play a little option 1 with a little mental game here. So what we want to do is we want to choose a value that's very, very close to 2 from the right. I'm writing all of this stuff out right now. If you were doing this on your own, once you get good at this, you can probably do all of this sort of processing in your head. But I'd say, okay, I'm headed to 2 and I'm coming in from the right direction. So things really, really close to 2 from the right, that would be stuff like 2.00000, 2 and a whole bunch of zeros and a 1. We can just keep getting closer and closer. And so what I do is I basically take that as my option 1 idea. And I'm going to take that 2.00001 and I'm plugging it in for x here. So I get 2.0000001 minus 2. As we come through this and start to clean it up now, what we're going to see is we'll have that 1 up on top. When I do 2.00001 minus 2, well, that's just past 2. So we know that what we've got down below here is going to be a positive number, and it's going to be a decimal point, the leftover stuff. All of that 0.0000001 stuff is what's going to be left inside there. And so when you read through this now, how you want to look at this is we're looking at the top here. 1 I would call a big number. 1 is very big and compared to these decimals you're working with here. So what you've got on top is you've got a positive big. When we look to the bottom, we also have a positive, but this time this number is small. And it's going to just keep getting smaller and smaller and smaller the more zeros we add on, the closer we get to 2. And so when you've got a big number divided by a very small number, you can see here from this example that would be getting huge. 1 divided by this very small decimal, if you type something like that into your calculator, is going to just keep getting bigger and bigger. And so what that's telling us is this is headed to infinity. So when we've got a positive big, when we've got a big over a small, we know we're headed to infinity. And then the sign on there that you're worried about, you always check the front up here. So this would be a positive. And so a positive over a positive would tell us that we're headed to positive infinity. And so what we're finding here is that the limit as x approaches 2 from the right is headed to positive infinity. And since you only need one answer, one side of a limit to head to infinity, the left or the right, for there to be a vertical asymptote, we also know that we're going to be looking at a vertical asymptote at x equals 2. So our limit answer was our graph is headed to a y value of positive infinity. Specifically, though, this is telling us that we have a vertical asymptote at x equals 2 because one of our limits equaled infinity.